Number 6. So, which row of the following table gives the correct information regard to the NSF molecule? NSF, when we heard this NSF, it's like National Science Foundation, which is in Sri Lanka. So, this is a molecule. Now, my first question is, to draw the structure of this molecule, because you should know how to draw the Lewis structure of this molecule. Otherwise, you cannot do this question in principle. Okay. So if you know the structure of this molecule, the first point is how to draw this structure. So as I explained to you in the structured essay last time, you can use that method. Or yes, you can complete the bonds very straightforward if you are confident enough. The first question for you guys is, they have given a formula, remember, right? So you have to draw the structure of this compound, NSF. So I will stop share again and use the board. The formula as they have given is NSF. Okay, but yeah, one might think like, okay, so maybe I can put nitrogen in the middle and sulfur in the middle and fluorine in the middle. So my question is, can you exchange or change the position of these atoms, which is given in the question? Because in the question itself, they have given a formula, that is NSF. So remember, if they have given a formula, you cannot change. For an example, let's say they have given a structure like this. This is a normal alkene. So in a question, if they have given the structure like this, remember, you cannot change its structure. You have to use this specific structure. But instead of this, they can give like this, C4 and H10. If they have given this one, then you can draw this one, then you can draw like this. Because still it will get the same formula. Okay. So remember, if they have given a structural formula, you cannot change. If they have given a chemical formula, you can change. Okay. Like a molecular formula. So the idea is clear for that. I hope the idea is clear. The next thing is how to draw the structure. So if you use our normal method, so there will be sulfur here, there will be nitrogen here, there will be fluorine here. Okay. So nitrogen, there are 5 electrons, sulfur there are 6, and fluorine there are 7. So 5, 6, 7. So 5 and 6 is 11, 11 and 7 is 18. So you divide 18 by 2, it is 9. And then there are 2 bonds already occupied. So the electron 9 minus 2 is 7. So in principle, you can put 7 electron pairs like this. 3, 6, and I can put the remaining here. Okay, I have put 7. Now check the charges 1, 2, 3, 4, 5, 6, 7. So 7 means nitrogen normally should have 5, but here it has 7. So there is minus 2 here. Sulfur is 1, 2, 3, 4. So 6 should be there, plus 2 here. And 1, 2, 3, 4, 5, 6, 7. There is no charge for fluorine because its octet is completed. And it should have 7. So 2, 4, 6, 7. It is completed. So the overall charge is 0. Okay. Now you have to minimize these two charges to get a good possible Lewis structure. So how to take this? You can add these 2 electrons here. This will be still the same. This will have no difference. Okay. This is 1. You can just give to these 2 electrons. So here still 1, 2, 3, 4, 5. Here it has a plus 1. 1, 2, 3, 4, 5, 6. Here has a minus 1. So what you can do? You can give another electron. So it will be like this. Okay. So in principle, now there is 2 electrons here. There are another electron here, and there are 6 electrons around this. So this is the structure. Now, if you draw this structure correctly, believe me, you will get only 1 minute to finalize the answer, because you can just check the oxidation state. That is the first statement that is given in the question itself. So how to check the oxidation state? So out of these two, which one is more electronegative, you think? That is the first point that you should understand here. Okay. So nitrogen or sulfur? What do you think? Then fluorine, you know, it will be the most electronegative thing. So there will be a delta negative charge here. There is a delta positive charge here. So like if you think this is -1 +1. So from this, you can imagine which one is more electronegative. Can you tell which one is more electronegative in the chat box? Nitrogen or sulfur? Lithium, beryllium, boron, carbon, nitrogen. Then sodium, magnesium, aluminum, silicon, phosphorus, sulfur. Which one is more electronegative? Okay, there is one answer, nitrogen. Okay, so it is very straightforward. Nitrogen will have high electronegativity. So if you think about the bonds, this will be -1 + 1. This will be -1 + 1. This will be -1 + 1. That is one criteria that you can do. Okay. But remember, when you check the number of electrons, 2, 6, 2, 4, 6, and 8. Octet completed. 2, 4, 6, and 2 electrons in the bonding. 8 octet completed. Here 2, 4, 6, 8, 10. Okay. Now tell me, these two are 8. Here there are 10 electrons. Okay. Now tell me why sulfur can accommodate 10 electrons. Can you tell why sulfur can accommodate 10 electrons? Straightforward question. You can use the chat box for that. So I will see the chat box. Can you tell why sulfur can accommodate 10 electrons, while nitrogen and fluorine have 8 electrons? Why sulfur can accommodate 10 electrons? That is my question. Even you can use the microphone, which will be very faster than this. I would like you to talk because it is more interactive when you talk. Sulfur doesn't obey octet rule. So that does not complete the answer. I'm asking, yeah, sulfur does not obey. Why? Why it does not obey? Remember, nitrogen and fluorine, they are in the second period, right? The second period, maximum number of electrons the octet configuration, to achieve octet configuration, the maximum number of electrons you can have is 8. But when you go down another period, sulfur, remember, it is in 3D, sorry, third period. I gave the answer. It is in third period, which is in principle, when n is equal to 3, you have empty 3D orbitals. Remember that. You have empty 3D orbitals. So remember these additional electrons other than the octet from period 2. Okay, when you have 3D empty, it will be filled to those empty orbitals. Okay, so that is why it does not obey octet rule. Remember that. Okay, so according to our this description, you can see nitrogen is more electronegative, so this one will be -1, -1, -1. This one will be -3, and this one will be +4, because -3 from nitrogen, here +3, -1 from fluorine, +1. So +4 oxidation state for sulfur, and fluorine, the oxidation state will be -1. Okay. Now, according to that, so I will share the screen. The only possible answer that is given in this table, which has a +4 oxidation state for sulfur, is this. So the answer should be this. So if you draw the structure very quickly to get the correct answer, it will not get at least 10 seconds maybe. You can automatically get the answer for that. Then the second is charge on sulfur. So charge, you can see, I told you there will be no charge because the additional electron will be added to the D shell. And as well as in the valence shell, you have 1, 2, 3, 4, 5, 6. Not more than 6 or less 6. It's already 6. So no charge on that. And the most important thing comes here, the hybridization. This part is very tricky. Okay? Because according to our organic chemistry rule, can you tell what is the hybridization of this? There is a triple bond here, there is a single bond here, there is sulfur. For an example, what I am telling here is now, if I have a compound like this, and for an example like this, that is what I am talking. Hydrogen is like fluorine, so I will connect this to another carbon like this. For an example. So you know, according to our organic chemistry, this carbon should be sp hybridized. Okay. But remember, this carbon is not, this sulfur is not sp hybridized. It is sp2 hybridized. Now you will be confused because this and this is more or less similar. So we take only the sigma bonds for hybridization in organic chemistry. That is why there are 2 sigma bonds. S and P will be mixing, and this is sp hybridization. But here also there are 1 sigma bond, 1 sigma bond. So the hybridization should be sp. But remember, here the hybridization is not sp. The hybridization is sp2. Then you think why? The idea here why this hybridization is sp2, that is beyond your scope of this, your syllabus. The idea is, remember, there is a lone pair here, but here there is no lone pair. Okay, so in fact, to accommodate these 2 lone pairs, okay, you need a sp2 hybridization, because here when sp is hybridized, the other electrons will be in unhybridized p orbital. But you would think here the additional electron might be present in the unhybridized p orbital. But remember, there is no unhybridized p because already all the electrons are occupied. So here the additional electron to electrons should be in a sp2 hybridized orbital. Okay, so don't think much about this. Okay, there is only 2 sigma bonds. This should be sp, but why it is sp2? Don't think about this much, but get the idea. This can be sp2, and this is beyond the scope. Okay, but to get the answer for this particular question, you don't even need to know this. Okay, because automatically if you get this one, the answer is correct. But you should know the concept.